Hey Lucas.
Hey, how are you doing?
Good, and I know now I know my audio is working. Hey Suzuki, long time no see.
Hey Devil. Hello guys. Good morning, good afternoon, wherever you are.
Hi,
Good
Suzuki.
morning. Hey Dan.
Hey, hey, Deval. Long time no here.
I'm back at work again.
Hey, congratulations. Now here comes the fire hose.
Oh yeah. Been dealing with that for a while.
Okay, we'll give a few more minutes for people to gather.
Good morning.
Good morning. Or good
Hey,
evening.
folks.
That sounded like Dan. Yep, that's Dan. Yeah, we seem to have a good crew here. Let me go ahead and get started. So welcome to the ostensibly EU-US friendly time slot. Although Elena has has reminded me that this is a Friday afternoon, so maybe not that friendly, but we do the best we can for this time slot. Um, Quick ground rules again for anybody that's new. This is an open source call. It's being recorded. It's actually on the you can watch past ones on YouTube. So treat this as another open source place. Uh, all the content here is suitable for things that you would openly discuss on the mailing list anyway. Um, Before I jump to the agenda, which is going to be, as always, informal and ad hoc as people have things to talk about, I think we've discussed a few things on the Discord channel. I did see a request from Alexander to talk about a topic as well, so I put that on the agenda. But before we go there, is there anybody that's new to this call that wants to do a quick introduction of just your name, organization, and your interest in this call, where we mainly focus on uh, anything combination computing is probably on topic across vendor, but we're primarily focused on this uh, privately assigned devices use case and all the work that needs to go into that. But I will pause it here. If anybody wants to raise their hand and do an introduction, we can do that first.
See, Catherine's hand is up.
Oh, okay. Yep. Go ahead, Catherine.
Hi, this is Catherine Zen. I'm from Google. So I'm the new sort of Google representative in the CCC tech, and I'm interested in getting all the CC related patches upstream into Linux as fast as possible. And that's why I'm interested in joining these calls. So yeah, I'm excited to learn a lot of the new developments in this area and working with you all.
Great. Well, welcome, and we share your motivation. Everybody wants this stuff to be upstream. Yeah, just a small matter of everybody has done it slightly differently across vendors, so we need to smooth that over.
It's no small feat, I learned.
Yeah. Okay. Anybody else? I think. Oh, go ahead.
Dan, I want to add an agenda item.
Mhm.
More a request for Dan to see if he could organize something complicated with either LPC or OSS EU for trusted IO in mind. Simply the fact is that you're going to have very limited slots at LPC, at the micro conference, and maybe we want a broader discussion and just gauge interest if there is enough interest to try to push for that.
Okay. Yeah, that had been on my. I hope somebody submits something, but yeah, we should probably actually coordinate that and do that. So I captured that as well. Any other opens that people want to get on the agenda?
Just on that point, I saw Jörg had sent a couple notes to the list on the 4th that people could check out, and we'll find the links for those while we're talking.
Okay.
Hi, Dan, Suzuki here. I just wanted to confirm if we are going to discuss the shared device. How do we plug that in? Is that covered by the bind mechanism? I just wanted to double check.
Yeah, that's kind of that everything thrown into that topic. Yeah.
Cool. Thank you.
No problem. Okay. Anything else? Otherwise, we will just start jumping into the tech topics and start walking through what's kind of happened recently. Okay. So this kind of started with Suzuki. You had asked about, hey, how does the guest side? So I'm actually starting with this second tech topic because it kind of bleeds into the first one. Is how does the guest decide or know what the state of the device it's working with relative to? Is it authenticated? Is it bound and accepted? All these kinds of things, and we're still working through that. But what I wanted, and I see Lucas is on, so he can answer any questions you have about at least the authenticated attribute, is that we want to try to keep the TSM side. So this case where some platform agent is doing the authentication for you, and and as part of the TDIS protocol, and that's usually vendor specific, but they all share TDIS under the hood, and TDIS depends on CMA, the native PCIe authentication mechanism. So Lucas is working on that native authentication flow, and that's going to be a attribute of a PCI device, and basically whatever ABI that presents to user space, we basically want to adopt and continue on the TSM side, so that as far as user space, like once user space understands how to check the authenticated attribute and get any other collateral like the SPDM transcript and these kind of things, that should be a shared ABI between those two use cases. Under the hood, we may be switching the source of the authentication from these two different sources between asking the TSM or doing it natively with the kernel. So, but the expectation is user space can't see the difference, but inside the kernel, you may be looking in two different places. We will have, so in Lucas's patches, the PCI device has an SPDM state that can tell you it's authenticated or not. That's when the kernel has done all that work itself. And then there will be a kind of a similar TSM, Trusted Security Manager state that also can reflect the same thing. And so it basically, it depends on, if all you care about is somebody somewhere has authenticated and checked the certificates, then we could probably do a helper that combines both of those things. But in general, it's going to be just an attribute of a PCI device. The place where that's pretty settled. Like I think we have a strong direction on where that's headed. The place that is still kind of open for proposals, and we're still kind of figuring it out, is how do we communicate that the device has been bound, locked, and accepted, and what are the mechanisms for a driver or user space to get involved in that flow. And so, and that's a piece that the native side won't do, because it can't do it, because it needs the only way you can reliably do it is when you talk to a platform agent that can make sure your device is locked and the MMIO settings are correct and the DMA IOMU settings are correct. So that part has to be done by the TSM driver. So we're going to be inventing new stuff there that the native side won't have. And so I guess so to your question, all that lead in kind of background, was your question about just authentication, or were you trying to look for how do kernel paths decide that this device has been through the entire acceptance flow or not?
Right.
Or is it both?
Thank you for explaining the proposals for the authentication and accepted flow. My question was more kind of orthogonal to this problem, is where right now all the devices for a confidential guest is not trusted, or in the sense that it is something that the host is emulating, or it's not a trusted device in the sense that you don't want to, for ARM-CC at least, we want to access it from a decrypted mappings. So we need some sort of infrastructure for the drivers, even without all of these trusted or untrusted coming in later. We need some way for the PCI drivers or the subsystem to map the bars as shared or decrypted explicitly so that they can work. So for the initial prototype that we did, we had a blanket shared attribute applied for all the IO remap requests, which may not be nice for forward portability, because some of the, similar to what the VMPLs is on AMD CVV, will have something similar for ARM-CCA, where some of the devices could be potentially emulated by a higher privileged component inside the trusted world. So we may need to decide, is this trusted or not, and apply the attribute accordingly. So how do we plumb that today to make sure that, okay, I know that this device, for example, we will know that, okay, the config space is in a decrypted state. I'm accessing it from the host emulated space, by which I know that, okay, any devices that I can see here are not trusted, or I should access them using the shared attribute or the decrypted mappings. So we need some sort of plumbing in there in the PCI IO remap bars code to make sure that we can specify, or the architecture can specify, okay, this is a shared thing, so use that instead of doing it under the hood. So that's where I was coming from. And when we get this authenticated and accepted attributes, that could be an indicator for the PCI to say, oh yes, this is an authenticated device. Maybe I should use the encrypted version of the IO remap or the PCI map calls.
Okay.
So I guess we could. So right now the authenticated bit is basically in part of the struct PCI dev, or actually struct PCI dev contains a pointer to a struct SPDM state, and that contains an authenticated bit. And I guess we could also have an encrypted bit in struct PCI dev, which indicates whether or not IDE has been set up to a particular PCI device. I'm not sure if that would fit your need.
This doesn't, I think this is not relevant to ID encryption, because I think what has been discussed is exactly the case where you emulate device within the confidential guest itself. So in that case, you don't have any IDE or anything, but let's say you're running it within in TDX, it's called partitioning, it's VMPL levels in AMD. So I think this is different what is being asked.
Yep. Correct. So it's slightly different from the ID encryption or not.
Right. So there's no
yeah,
ID
exactly.
encryption. The device is actually emulated within the confidential guest, and it's secure to access within the guest private memory.
Yep.
So Suzuki, what type of devices are you looking for to emulate here that require a secure communication channel between both VMPLs?
So for example, it could be a gig distributor that may be emulated by, or it could be, so it applies to all other devices. Like it
But
could be
GigD is only MMIO, right?
It is only MMIO. I'm just saying. Sorry. So it could also be a PCI device that the paravisor may be, you call it paravisor, the higher privilege level may be passing through. It could potentially do the, all the TDISP flow and provide this device over here in a PCI config space, which is in the in ARM CCA terms in the protected IPA space, and the guest can see that, oh, this is a protected device appearing in the protected half, and I can apply the protected attribute for the bus or bar remappings.
Or you could even take it a step further and basically just put your ECAM into protected space, right?
Yep. So that's what we do. So currently, all the host emulated ECAM is in the config bus. It appears in the unprotected space. So we know that the config space is unprotected.
But it doesn't have to be.
It doesn't have to be. So if it appears in the protected space, you know that, oh, this is something that the host is the protected space is emulating. So we know who is emulating this device, but we need some way to pass it down to the IO remap calls that originates from the PCI driver space to say that, look, I know that
it's not only PCI, it's every layer. Like literally, even platform devices need to know that. If you have a, I don't know, like a CRB range on a TPM, for example, and you want to just IO remap that and have the backing store be memory, which makes sense for a CRB, then you literally need to make sure that the remap call happens on not shared or non-shared.
Yeah. So a little bit more background to that is we can use the base address that you see for a device, and you can see that address and detect, oh, this is a unprotected or protected address. But the problem with PCI is that we don't want to do that for PCI bar addresses that you read from the config space, because we are limited by the 32-bit bar addresses, and if you have to force all the devices to use 64-bit bar addresses, that's kind of cause additional restrictions on what devices the VMM is emulating. So
what?
So let's see if I can ask a clarifying question. So, like, because we thrown out a few concepts here. So you're talking about whether we can map the device as private or not. This is different from whether we kind of trust an emulated device or not. But I guess those could be aligned. But you're really more interested in just when do we map this thing private, when do we not?
Actually, it's not different. How can you not trust your device and map it into your private space? That's a suicide from security.
No, but the difference is that you can't map a fully emulated device as private because you only have the shared option. And what this is
but if it's emulated within the confidential computing guest, you can, and it's safe. If it's a VTPM which is emulated in VMPL 0 or L1 VMM, that's safe to do.
Yep.
It's fully emulated.
You're saying emulated with private memory from L1? That makes sense. Okay, that makes sense.
Yes. This exactly is the case being discussed. VMPL 0 is empty analog. You can also think of older devices which might make sense to emulate. It's not just VTPM. For example, RTC. I mean, we still don't have proper secure time of a day. So you can actually do this in VMPL 0 or L1 VMM as well, and you can emulate a proper RTC device, and you can, get to secure time from remote network service and supply it, properly to the guest. So all kinds of options are possible in there.
Are we talking about enumerating the current configuration of the device, whether it's secure, authenticated, and accepted, versus are we going to talk about emulation of the enumeration of the capability of the device to become private and protected? Which one of those?
I think we've kind of up-leveled it to, in general, this device concept, whether it's emulated or PCI or not. How do we? What is the Linux signal to say map this thing as private and communicate that the resource you're trying to map needs to be mapped privately?
But is it a capability question or a state question?
It's well, probably both, right? Like, is it because especially for devices that can be converted, it also becomes a state issue.
This particular devices cannot be converted, which has been discussed. They're provided from beginning, and they have to be provided in the private, in the VMPL 0 or 1. So it's not something, it have to be fully emulated.
Yeah, but the question is, so we do have enumeration for capability, right? And we do have the state enumeration through TDISP, get TDISP state. So what is missing? I'm trying to understand what is missing.
So I think, well, Suzuki, right, are you specifically worried about, I mean, PCI first, right? We can probably solve the platform device thing has to be solved separately. So we probably need Linux to understand the same concept.
Yeah,
go ahead.
Right. So for example, we're just talking about, we know that a device is emulated by the host. That is, now it is untrusted, and as such, we should access it using the shared attribute as in decrypted addresses. So we don't have anything in the PCI today to do that.
Right.
So don't you have device capability? So first you have TIO capability, which you can be emulated, right, and exposed through PCI config space. So if you want to assign to a nested guest within the TVM, you want to assign a device to it, can't you just discover it through regular PCI enumeration, whether it's capable? And let's say it's capable, but currently it's not secure. Can't you just discover it through, well, so you see it's a TDISP capable device. Now I want to know if I need to address it as private or shared. Then you can query its state, right?
I think we have
but this won't be a TDISP device, or it might not be a TDISP device. It's kind of orthogonal. Yeah, it's orthogonal. Like VTPM is not TDISP device, but it's still secure if it's emulated in L1.
That's true, but I'd like to set those aside because we have to solve the devices that can have all this enumeration first, and then we can circle back and say, hey, what can we reuse from what we learned from doing the PCI side, where things can be TDISP and things can be enumerated, like Ari is saying, and then populate that same kind of knowledge to the platform device side. So yeah, but I think Ari, to your question, like we know we have all these mechanisms available. I think Suzuki is saying, like, what are we actually going to do? Like, where is it going to show up? How do we do that? And so yeah, so that's the TBD work in progress stuff right now. Let me kind of segue into this, because that really comes back to, like, how do we know when the device is bound, and how does that work? One of the conversations that we had internally that we need to move out into the public sooner than later, but one of the kind of an aha moment we had was that we've increasingly found that that TDISP kind of assumed, and like all the implementations have kind of assumed so far, that binding a device is a VMM responsibility. That's fine, but in terms of when to do it and why, and the motivation to do it, that's really from the guest side. Like, the host doesn't know if the guest is ever going to bind it or not. The guest needs to. There are going to be several scenarios where things become unbound, like like resets and errors and all these kinds of cases where we're probably going to need to rebind the device. People want to rebind the device to replay nonces and these kinds of things. So it's having the VMM be the initiator of bind is awkward all those reasons. And so part of the aha moment that we had was like, in terms of bind and the responsibility of the VFIO should have, VFIO's responsibility should be similar to what it does for mmap emulation, where it does the mmap, but it waits until the guest faults to actually install the mapping and get all that set up. So it's basically guest triggered population, and want to match that flow for binding, where VFIO sets up the context, whatever it needs with the local TSM driver, whatever the platform is, and then later the guest can bind at will, and VMM host side doesn't need to, like QEMU doesn't need to issue bind requests. It just needs to set up the context.
Does VFIO provide a mechanism for the host to notify it about error events, or maybe the host wants to reset the device and don't just go and hot plug it out of the guest, right? Is there any notification mechanism already?
We probably wouldn't have one, like in the sense that if you want to destroy your device's context, you can. Denial of service is not in the threat model, and so we wouldn't need to teach VFIO to keep its hands off. Like if the administrator has a reason to reset the device, it can.
No, I'm talking about the opposite, recoverability, right? Mm-hmm. Providing service to the guest without forcefully tearing down a device and causing the guest to panic and die, or do we have a standard mechanism from the host side in VFIO to?
No.
Okay.
That's basically what we're our error model for the foreseeable future is probably going to be guest driver timeout. And when the guest driver times out, what does it do? And this is why bind needs to be something that the guest can trigger, because what the guest might find is something times out or something errors, and it can enumerate that, hey, I'm no longer bound. I need to get that set back up again. So that would be kind of independent of, like, VFIO's only job there is to make it so that when a guest request arrives, that the host side can do what it needs to do to recover the bind state.
So Dan, you're basically saying that the binding step for semantic should be guest driven and not host driven. Is that what you're?
It's basically have a guest to host mechanism, whether that's a per vendor GHCI GHCB call to do that, because I think every vendor so far has that actual who actually runs the command is coming from the host side.
Yeah.
But in terms of the stimulus to say go do that stimulus, it looks like it needs to be routed from the guest to the host.
But in which case, I mean, what's the? It seems that you have a compelling use cases for the guest actually sending a stimulus back to the host to basically ask it to initiate a binding mechanism. Is that what you're trying to say here?
Yes.
But on would the nominal flow be for the host to actually initiate the bindings?
So this also why I put in this note about pre-bind versus post-bind. We have this, like, the expectation is that we need, like, even though it's complicated, we kind of need to consider the error case as a first-class citizen, and that means that we don't bind before the guest has had a chance to say yes, please bind, because the
okay. I I think I fully agree with this. I think it's to me, the binding semantic is basically the host requesting the TSM to bind something into the guest, and this is just the final decision is coming from the guest, and the guest basically accepts it or not.
Right.
And yeah, so binding is just it's the host trying to eventually plug an interface into the guest, but it's definitely a guest decision.
Oh, true. Yeah. Yeah, and this also we might need a glossary of like, because when I say bind, I mean like basically taking the device from unlocked to locked to run, and
yes, yeah.
Depending on the vendor, like it might go straight from unlocked to run, but some vendors might do a locked in between. But that we have an unlocked device to begin with in the guest.
Yeah. Yes.
Yes, I think we've also talked about that in the case that there are some devices that require configuration through normal PCI, right, unsecured PCI, before the device can be transitioned into the lock state. So, correct. I mean, that's certainly a use case that needs to be supported. I guess I'm not clear, Dan, if you're arguing that there's no use case for a pre-bind model and that everything should be done, it's what we call post-bind. Not sure if it matters too much.
I'm not sure if it matters. Well, the reason why I think it might matter is this comes back to ABI, in the sense that is our life more complicated by the fact that we have this pre-bind thing that we have to consider also in the post-bind flow. That are things simpler in the long run, even though post-bind has more mechanics to it, are we better off in the long run having never supported the pre-bind case? And that ABI and always asking ourselves the question for the next 10 years, like, oh, are you?
What's the motivation? What's the motivation for pre-bind? Is it performance?
I think it's simplicity. It's like easy to implement first, but then
as soon as you need to rebind it, you go back to the non-simple, right? Anyway, so
correct. Yes, right, yeah.
So it doesn't provide you any code simplicity or architecture simplicity, right? So it seems like the pre-bind would be suitable for a case that you want a faster boot time from the perspective of the guest.
Well, but if you look at, go ahead.
Not just those cases, right? But consider a case like a paravisor. You may want to have the device bound by the paravisor and then passed on to the guest itself.
When you say paravisor, you're talking about an L1?
Yes, a replacement of an SPSM. Sorry, this is an AMD specific technology.
Still, the paravisor may need to rebind anyway, right? So what's the point?
Yes, but all the complexity will be in the paravisor, not in the guest.
No, but you can still have all the I mean, from host perspective, you have a monolithic guest,
I see your question. Sure.
Right.
Dan, is pre-bind basically equivalent to the transition from unlocked to locked?
Yeah, basically.
Is that the intention?
Yeah, pre-bind, a translation of that terminology is locked before the guest starts running, which is actually, if you look at all the kind of proof of concepts that are like, at least the two I've seen, they do that, and because I think it's a proof of concept, but I think that's probably one of the proof of concept things we need to jettison for upstream is that it needs to be more sophisticated. It needs to be guest initiated.
Well, I guess one reason why I'm not sure if it matters is that when a guest device driver loads, the device could be in any state, right? Because we may have unloaded the driver or something. And so I guess the question is if the device driver comes up and it sees the device is already, in the run state or something like this, what does it do? Does it just see if it can accept it and move on? Because at that point, it looks no different.
Right. Yeah. I think the guest side always has to be prepared for the device to be in any situation. The simplification we get by not supporting pre-bind is host side complication. Like we don't have to support an ABI that the host triggers bind it on its own. that ABI never exists on the host side. It's always a reaction to what the guest does, and we can kind of keep that kernel internal. We don't have to.
I mean, if we say only post bind makes sense, then why do we need a guest to be able to support pre-bind? That's something I missed.
Oh no, but to David's point, like it could be the case that your guest k execs or you get like.
Oh, okay. So it reloads a driver with an existing state. Okay.
Yep.
Another aspect related to this lifecycle is unbind, right? From some reasons, the guest may see, may need to, remove the device from its TCB, right? Even dynamically, and kind of get a proof from the TSM that the device has no longer access to its TCB because the guest may want to stop provisioning private data to the device, right?
Mm-hmm. Yeah.
So it's kind of the symmetrical for bind request is unbind request, right?
Yes. Either by force or accident. Lucas, I see your hand raised.
I just want to point out, because you said that the guest needs to be ready to handle the device in any state, but actually VFIO on the host performs a reset of the device before it passes it through to the guest. So I think the expectation is usually that the guest gets a device in a pristine, non-initialized state. Just wanted to point that out.
But I think this is the guest shouldn't make any. I mean, shouldn't make any assumption on the device state. It's not going to trust anything. It just should assume that the device could be in any state and be able to reject or accept it based on this.
Yeah. It could have been an accident. Whereas like the guest is like, I don't know the nonce that was used. Any nonces that were used to set up this device context before. I'm going to undo it myself. But the reason I brought up this whole pre-bind is important case is that means that we have to have devices attaching in shared mode at the start, and that's the expectation. But I got pointed to a thread. It was Paolo responding to some AMD patches. Were effective. I put the links in the Discord. Effectively saying like, oh, we don't need to worry about shared devices so much because when we get to TIO and TDS Connect and these kind of things, that'll be he's basically assuming that PCI devices will just arrive in private mode, so we don't really need to worry so much about shared to private page conversion and what that means for VFIO mappings. And I think so that's something we need to go after in the short term, which is teach VFIO about page conversion, and revisit that contention from Paolo where he basically said QEMU shouldn't need to worry about this long term because it'll be obviated by these secure device technologies. Take a look at those threads I posted in Discord if you disagree with that assertion, but that's my read, is that we need a QEMU calls them a discard manager. I think we need those. We need one of those for page conversions and updating IOMMU mappings. So yeah, so that's more of a kind of a report out on what's happening there. I did want to go ahead, Gobi.
Okay, then this is a question on your previous earlier statement on the authenticated state. So it could either be platform authenticated or TSM authenticated, correct? So how would guest know the difference? Should it know the difference at all?
At least, so I think that on the native side, we have these two states in the PCI dev. One is the native one is the TSM one. My expectation is that we would have a similar guest TSM driver that would do the same thing. So you could look in the same place. You basically say, hey, there's no SPDM authentication for this TDI, because most TDIs, well, almost all of them, are not going to have their own SPDM session. But you will see, though, the TSM driver attached to this thing, and the TSM driver is asserting that this thing has gone through authenticated state. This is a like basically anything that can convey an interface report will probably be considered authenticated, and then from there you trigger bind and do the acceptance flow. So it's really a matter of asking the TSM driver, is there something supposed to be here or not for that level of.
So I'm trying to understand. So you're saying that if for some reason this authenticated state is set by the platform, would the bind fail?
Well, like, go ahead. Who's good?
If the authentication has happened from the platform, the TSM wouldn't own the SPDM session.
Yep, correct.
So if when the guest is willing to accept a TDI, it should ask, or it must ask the TSM about the existence of a TSM control SPDM session. And if there is no such thing because the platform has already done that, then the guest would reject the TDI. The guest will trust the TSM to tell it if the SPDM session is owned by the TSM or not.
Yeah, exactly.
So even if the host has performed authentication with a device natively in the kernel, it is perfectly possible for the TSM to subsequently set up an SPDM session. Because the first request sent to the device, which is get version, resets the SPDM session state.
Yeah, absolutely. But the TSM should basically try to establish an SPDM session, and which would basically reap the existing one if the host has established one. If it cannot establish an SPDM session, then there's no TDI from this specific device should be accepted, because the TSM would be able to tell the guest that it hasn't been able to establish an SPDM session, so it shouldn't be accepted.
Yeah.
Do we expect to create some kind of repository for storing the entire authentication and policy story, so we were able to support kind of layering authentication? Because maybe some layers in the guest authenticated the device and say, okay, that's fine, I'm willing to accept it to the TVM TCB, and then maybe later, a driver, remote verifier is going to also be interested in checking the, all the device information and policies and measurements, or even recollect them in order to decide whether to provision additional data, right? Maybe a new tenant running on the same TD or TVM, or new tenant that wants to provision new data to it, wants to ask the same questions again, right? So is it going to be layered? And can you re-authenticate?
That's in scope, and like everybody asked for that. I feel like that when this operation is happening, everybody is going to want to get their fingers into it. And when I mean everybody, I mean user space and endpoint drivers and the PCI core. They're all going to have to kind of all give a thumbs up about it and have a chance to give a thumbs up about it and re-trigger it. So I think we need that up and down and left and right for all this stuff. So go ahead.
No, I was going to say that I believe the TSM should provide an interface for the guest to basically request a fresh attestation evidence from the device. Any guest, any part of the guest, any application should be able to just request the TSM for indirectly request the TSM for a fresh attestation evidence, so that if you want to run multiple verification flows at any point in time in the life cycle of the guest, I think you should be able to do that from user space, from guest user space.
And I think that at this point we'd also try to match some of the semantics that we have from the native side, at least for replaying or for allowing nonces to be passed and these kinds of things.
Yes. Yep.
Yeah. I'm moving kind of fast to the topics, so we can definitely spend more time here. I wanted to check in with Alexander about confidential K-exec and whether 15 minutes of time is enough to introduce the topic, or if he wants to have
easily.
a fuller session next time.
Yeah, no, like it's the basic idea is super trivial, right? What I've seen these KExec patches floating on the mailing list, and all we're doing with that KExec is we are trying to tidy up after ourselves with a kernel to go and execute another kernel. But at that point, you need to basically forced to use a TPM and all of the what's it called, like the secure KExec handover IMA and use IMA in order to actually make like even remotely be able to reason about the confidentiality of that target system after KExec happened. And if you keep adding these things, complexity just goes through the roof, right? Like in order to actually make sense of my system, I now need to, I don't know, like download 5 megabytes of IMA log, then try to validate that against a TPM that is implemented in an SVSM. Then I need to go and get the PCRs as well, validate that quote against the actual measurement of the confidential computing solution. It just like completely blows up the complexity of validation. While life could be really easy and with these COCO environments, if we could just always rely on the measurement of the COCO thing itself. So if you look at the way things like Cloud Hypervisor drive micro VMs using CephSMP, I don't know if it does TDX yet. You essentially just launch a VM with a preloaded kernel and InitRFS that contains everything you need. You just directly boot into that, and then your launch measurement is a full indicator of the system you're running. So if we had a KExec, like I don't know if we would call it KExec at that point, but if you had a reboot API that allows you to preserve previous memory and make that the new initial seed for the new VM, maybe a bit of CPU state as well, you would solve 2 problems, right? One is you could actually continue using that micro VM style flow with a KExec mechanism. So you could have a VM, the VM could update itself, even if it was basically just only using COCO measurements without any of the TPM complexities. And you could still update that stack without stopping and starting the VM for real, right? Because that may be an operation that your environment doesn't fully support. For example, for us, what we would like to do in AWS is I would actually like as the default case for these COCO environments, always want to boot into an untrusted environment and then have you go and do whatever you need to fetch your data that you currently require today to become a confidential environment. Push that in and just reboot yourself into a confidential environment. The second part where the current story without this slightly falls apart is how do you update an SVSM? So I understand how you can update a kernel if you go through a lot of hoops and you basically start to emit an event log and you go through IMA and you do TPMs and you do a lot of very complicated things. But how do you even remotely update the TPM emulation? Like what if there is a buffer overflow in your TPM emulation? How do you go about that? Like how would you go and update your system, and how would you get yourself into a safe state, ideally without interaction from your cloud provider because they aren't trustworthy in the whole trust model of COCO VMs, right? So you want to own your own destiny and be able to actually resolve a security issue with a full launch time measurement of exactly the code that you are expecting to execute. So I think we need to be in a world sometime with confidential computing VMs that you can, as a user of a COCO VM, reboot into exactly your state that you are that you require. A lot of words for no work, right? So I have basically
I was waiting for the patches. Yeah,
Exactly.
that sounds great.
Exactly. Yeah. So it sounds good. It's like the concept is easy, right? And we just need the patches. So it's I'm basically stumbling over two things, right? One is I would actually like to get somebody else to implement this, but this is a different conversation. We don't need to have this here. The actual really thing that we need to get up in this forum is there anything that conceptually would be breaking in that concept in this flow? Like, can you think of something I am intrinsically familiar with how SEV SMP works, and I know that it absolutely would be the right thing to do there. Is there anything in other environments that would fall apart? And how would we go about transferring that state between an old VM and make that be the shared seeding point for the new VM?
I mean, even in SMP, isn't that a complete restructure of how virtual machines work? Like you're taking away, the virtual machine part, and you basically get a, ROM kernel with a container, I assume you're booting?
Not sure what the difference is. So today, what you're getting, the way a VM boots is it basically has a set of CPU state and a set of memory state, right? And all you want to do is you want to be able to tell the hypervisor, remove my old VM context, create a new VM context, make my initial CPU state this, and make my initial RAM state this. And then you just
I guess at a high level that makes sense, but in practice, we're typically booting from like a boot device, and you're emulating a physical machine. This is a pretty big change to that in my mind.
Why?
Like who's reading now? Who reads the customer's boot disk? The hypervisor has to read that, parse out the kernel, and place it into memory now.
So the flow would be pretty simple, right? The flow would be, at least the thing I'm envisioning, is you can do the readout from disk. You can do that in an untrusted environment or in a semi-trusted environment, right? What you care about is the actual target payload you really want to have that trust stamp on. So the real measurements for. So what you can do is if you boot up with an untrusted VM, which can still be in SMP. So you boot up with an untrusted VM, your untrusted environment then does all the disk reading, boots like today, like it literally just goes and runs a full UEFI stack. It boots that, then that just executes a Linux environment. You could even boot into a full Linux OS if you wanted to at that point. And then even ideally through a KXSig API, you just upload the new target firmware plus kernel plus initmfs payload, and then say reboot into this. So it's basically the only thing that actually changes the device model in the hypervisor part is that you still maintain the device model as it is today, but you would need to introduce a new hypercall that says preserve this memory and create a new VM context out of that memory and the CPU state. Yeah, and that would basically be a PV reboot device, right?
Yeah. Okay. I understand.
But if this initial launch VM that's going to do the reboot, like if that deploys a persistent rootkit that survives that reboot, like how does the new environment not trust that my setup environment wasn't leaving landmines for me to trip over?
Where can it install a rootkit? Where can that malicious VM, a malicious initial bootstrap VM, where could that install a rootkit?
I guess, yeah.
Who provides this all these images? Because I guess customers won't have all that built. So
say again.
So these images with firmware plus kernel plus an initmfs, where does it come out? The new one, which one we want to reboot?
Ideally you would have them be part of of your operating systems, right? So if you want to do a general purpose OS, instead of just shipping UKIs, you would ship a UKI that just also includes the firmware image.
So Alexander, if you're doing all of that to boot typically and then kind of take a snapshot and move in, the amount of data that goes into that launch digest is now huge. And we already have the TPM to kind of prove the, to prove the measurement of that state. So
would you just rely on the TPM measurement of the pre-snapshotted state to get your expected launch digest, or how would you derive the expected launch digest in that situation?
I would basically split my you don't want to have like the only thing you want to transfer, only in quotes, because it could literally be gigabits of data. The only thing you want to transfer over really is firmware image plus kernel image plus init RFS, right? It's the only data you want to preserve. You don't want to preserve any other state, because as Dan said, that basically opens the door for any rootkit, because if you make things complicated, they open doors. So we would basically at this in this mechanism, you would literally remove any TPM that was there before. No TPM starts from scratch. There is no previous TPM state left, because you are resetting the full VM context, including any SVSM, for example, which then means you can also install and update a new SVSM that you actually as a customer own, which means you don't need to put your trust into somebody else's SVSM, which is way better than anything else you could do.
But how do I go from you've measured now the running firmware, running kernel at a point in time, and a running init at RAMFS, which will look different than their binaries that are that come out of the build process. So how do I get a binding between artifacts from the build to what they look like when the snapshot occurs?
I don't understand why they're different.
I guess you're just loading direct. I mean, maybe naive question, but you're executing kernel, right? And there's kernel does modifications, and it's not a write only or read only system, right? So there are changes to the memory state as the firmware is booting, right?
So what you're doing is okay. We have the pre KExec and the post KExec state, right? So pre KExec basically can do whatever it likes. It just needs to make sure that it puts the payload into shared memory so the hypervisor can extract it again on KExec. Then post KExec, you are in a completely new VM context. Everything that was there before, every other private page that existed, is gone. It doesn't exist anymore. It's literally a new virtual machine context.
I understand that, but I don't know how I get my if I have trust in my build artifacts,
yes,
how do I gain trust in the new image? Which I don't understand how it would be an exact like there's a function that's performed on those build artifacts and they become the snapshotted VM, right?
What function would you think of? Like
I mean the function of like running the code and it like you're generating a snapshot. So I don't understand that, but I guess we could take this on email.
What snapshot? I think there's a fundamental.
You're saying that there's a snapshot of the virtual machine. Sorry, Dave.
Okay.
Well, I was going to say that maybe these details are getting to the point where we need to see code, and some people can be like, "Oh, that's the thing you're talking about." But I think conceptually, I like the idea of one, guest ownership of the collateral they're deploying, and two, not needing to start over from scratch after you KExec. Like that, there's something smarter that says, "Hey, you did all this work to attest the launch state. Maybe don't throw that away, and continue from a point."
So how does attestate, or how does any updating of SVSMs work today? Because this is literally just the same thing, right? Like instead of just pushing everything up one layer and saying SVSMs are always going to be eternally secure, which is not going to be the case. What is the update story for SVSMs that we have today? Without a mechanism like this, you don't have one, right?
One, I'm not the right person to answer that, and two, like we're running out of time, so it's one of those like, oh, that's a very complicated question, very good one. Anyway, we're out of time.
Awesome, Dan. Love it.
But my main question is, why wouldn't you just, let's say there's a fixed number of versions of updated SVSMs. I assume you're probably not necessarily rolling these out that often. Like, couldn't you tick this forward, have some mechanism for ticking this forward through the creation API of your VMs? Maybe I'm misunderstanding.
It's a tenant separation problem. I want to put the cloud provider completely out of the equation of owning the SVSM.
I see what you're okay.
Right. So either you trust us or you don't trust us. And if you don't trust us, like if you trust us, by all means, we have an amazing product. if you don't trust us, then I think that a half-baked solution where we provide some elements but not others is always going to invite question marks, right? Because, like, honestly, if we build an SVSM and we are the main entity that does that, and researchers end up doing responsible disclosure, we by definition have like 30 days of 0 days, which is not what you want as a customer. But as Dan said, time is over.
But I appreciate that. Yeah, I put a link to the Discord channel to keep things going if you want to have a conversation there. That's not for things that maybe not ready for a mailing list post. Either one, it works great. We do have this call again in 2 weeks, although that's in the super not European friendly time. That's more Asia, Australia friendly time. But we will be back here again at this time slot in 4 weeks. Yep. So we will see you guys in the next one. But yeah, feel free to reach out. Go ahead. Real quick.
Will we be here 4 weeks from now? I mean, it's a long weekend in the US.
Oh, I need to think about that. Well, I mean, yeah, we might need to reschedule, or let people come in from vacation, which probably won't work either. So, yeah, I'll take a look at that. But in terms of planning for LPC, we should probably have that conversation immediately so that we make sure that we get our topic into the microconference.
I'm pretty sure there will be a trusted IO topic at the microconference. Having said that, we may not have enough time. And I'm just trying to figure out if what we want to do is get something before and then have a readout at the microconference, or, you know, how does that work? And
yeah, I mean, and I'm basically run this call like a microconference anyway. So like we always have this call. Maybe we could do a readout from some consensus here at the microconference and keep the conversation going.
I do need to go. So.
Yep, we all need to go.
I'll send an email about that.
Okay. Thank you for the great discussion, Dave. Yeah, excuse rushing through things, but yeah, feel free to reach out to get on the agenda for the next call, and we will see you guys on the list. Thanks, everyone.
Thank you.
Thanks, Dan.
Bye.
Thank you.
Thank you, Dan.
Thanks.